Namaste. This is the first video of a series of videos which are intended to give you an overview of interface controller design. In this video, I will briefly describe what exactly are interface controllers. So, interface controllers and why they are required. And we'll also briefly look at a typical configuration of an interface controller which is based on a host processor interface. So what exactly are interface controllers? We know that all modern designs, all modern VLSI designs, they are basically systems on chip where you will have several processors, applications, communication interfaces, and so on. So one of the important aspects of SoC design is to understand how to interface a specific device to a processor. Now, why are we so concerned about this or about this aspect of chip design? We know that almost all processors, they have a standard interface. So if you take a processor, you can take the most modern processors of the current generation. The interfaces remain more or less the same. And what are the interface ports that you typically find in a processor? You have the data bus, you have the address bus, some pins for the direction control, the read write control. Then you may have the interrupt pins, and of course, reset and clock. So these are pretty much the set of hardware interfaces that you would find on any processor. This is more or less standard. But on the other hand, in an SoC or even in a traditional processor-based system, the processor is expected to communicate and control heterogeneous devices. So in any system, the processor has to communicate and communicate with and control multiple heterogeneous devices and peripherals. Example, of course, the first example that comes to our mind are the memories, then various IO devices like displays, keyboards, printers, and so forth. And in modern embedded systems, you will also have other interfaces like sensors, bus interfaces, and so on and so forth. So one thing you can observe from this is that on the one side, you have a standard interface, that is the processor interface. On the other side, the processor is expected to interact with devices which have heterogeneous uh, interfaces. For instance, memories, they have more or less a similar interface to that of the processor. They have an address bus, they have data buses. Maybe they may have additional lines like BC and uh, some related handshake lines. But if you look at IO devices, many of the IO devices may have hardware interfaces which are totally different from the processor interfaces. Similarly, the sensors and buses. So what I'm trying to drive at is that these devices cannot be directly interfaced to a processor. Moreover, in any system, there may be several devices which would like to communicate to a processor, which means that a direct interface between the processor and these devices will not be possible. So the devices basically speak a different language than the processor. Moreover, they may have different timings than the uh, rate at which the processor is uh, processing its data. So all these, suppose we sum up, devices have different interfaces. Their timings vary. For instance, if you take a very simple IO device like a mouse, the mouse communicates its data at a time frame or at a time scale which is related to human actions, which is related to the pressing of the mouse buttons by our fingers. Whereas this data is processed by a processor which is functioning at a clock frequency maybe of the order of a few hundreds of megahertz or perhaps 1 or 2 gigahertz. So there is a mismatch. And the data format at which these devices communicate, they are also different. For instance, you may have a serial device. You may have a device which is communicating using a serial communication protocol. Or you may have a device which is having a totally different data format than the processor. So all these factors, they build a case for the dedicated interface controllers. So I think by this time you might have had a vague idea of what interface controllers are supposed to do. So first I'll show you a logical diagram of how the processor, the interface controller, and the device are connected. Of course, this is not a physical connection what I am showing. It is just a logical representation. So you can see that the interface controller acts as a bridge, and on the other side you have the device. So you may have a single interface controller for several devices. For instance, a DMA controller which talks to the processor, and on the other side it talks to a device. Or you may have dedicated interface controllers for specific devices. So this is where the interface controller is positioned in an overall processor based system or even in a modern SoC. And in the VLSI industry, quite a lot of effort goes towards designing such interface controllers, because even though the processor interface remains standard, every other day you get a new device which has to be integrated into an SoC based system. So there is always a need for either upgrading the present interface controllers to accommodate new devices or for designing totally dedicated interface controllers for specific devices. Now, the good thing is that the methodology for designing such controllers, that is more or less the same. If you understand a rudimentary interface controller design, it will help you mold your thinking towards designing controllers for even more complex devices. So the objective of this small video series is to give you, or is to mold your thinking towards uh, identifying the important blocks and designing the important state machines that are typically part of any such system. Okay, now let us see what are the typical parts of an interface controller. We have already seen that on the one side, the interface controller talks to the host processor. And on the other side, you may have different devices which have different interfaces, which have different data formats and so forth. Therefore, it follows that any interface controller will have a host part, which is typically a state machine that is concerned with primarily communicating with the processor. The idea of the host controller will crystallize when we take this design process further in the subsequent videos. The second important component naturally will be the device controller on the device side. So the device controller is concerned with generating the handshake signals and the data signals that are required for communicating to the device side. Now, from the design perspective, what are the different aspects that we need to look into when we are designing an interface controller? The first thing that we need to look into is the hardware interface, which consists of the input and output ports of the interface controller. And that is typical in any VLSI design flow. We will have to first look at how the chip is communicating with the outside world. The second part of the uh, design will be to figure out what are the software interfaces. Now, what exactly is a software interface? The software interface will consist of the control and status registers, which provide the means for the processor to initiate transactions and also to determine the status of completion of different transactions on the device side. So if the processor wants to initiate a data transfer to the device, then it writes some control word into the control register. And on completion of the transaction, the controller, the interface controller, will update certain status bits in the status register. So the software interface consists of these registers, which are used for control and monitoring of status of different transactions. Then typically you will have data registers. Data registers provide the data, the content that is transferred from a device. For instance, if it's a serial device, like a serial uh, port, then the serial data that is received from the device is converted into parallel form and it is stored in a data register for the processor to retrieve it later. Or the register will consist of a FIFO, where several words of data are stored for the processor to retrieve later. So the data registers also form part of the software interface. Then, of course, for controlling all these operations, the control path will be comprising the state machines, controller, finite state machines. So essentially, our design process, the design effort will be focused on uh, building these three components. So first, we will define the functionality of the design thoroughly. And once we are clear about the functional steps on the host and device side, then we can easily come up with the hardware interface. That is, what are the pins that form the periphery of the chip. And a clear understanding of the functionality will also enable us to identify the control words that are required for initiating the transactions and also the various status bits that have to be provided in the status register. And also, we will be able to determine the type of data registers that have to be provided. For instance, if the device is capable of bulk transfer of data, we may have to provide either several data registers or a FIFO-like structure. Or if only one word of data is transferred in a typical transaction, then a single data register will suffice. So all these decisions are based on the type of device that is interfaced to the interface controller. And controller FSMs, of course, the state machine, the state, various states of the state machine and the assertion of the control signals, they are uh, designed based on the functionality that we define at the beginning of the design process itself. So that's the end of the first video in the series. I hope I have given you a rough overview of what interface controllers are all about and set the context for starting off the video series. So in the next video, we will look at the hardware interface, and before that, of course, we will first take up a typical interface controller, a simple memory interface controller. I'll keep it very, very simple so that we are able to learn the design process rather than getting carried away by the intricacies of the various transactions. So we will take, in the next video, we will take a memory controller as an example, and we will try to list out the functionality that is expected from the controller. And from that understanding, we will try to construct the hardware interface as well as the software interface of the interface controller. So that will be the agenda for the next 1 or 2 videos. So that's all for now. We'll again continue in the next video. Thank you.